Welcome to the second part of 9.1, Systems of Linear Equations in Two Variables. Today we're going to focus on just two application problems. So this first one is a supply and demand problem. So suppose that number x of bushels of apples a farmer is willing to sell is given by x equals 100p minus 25, where p is the price in dollars per bushel of apples. The number x of bushels of apples a grocer is willing to purchase is given by x equals negative 150p plus 655, where p is the price per bushel of apples. We want to find the equilibrium price. Well, something to keep in mind, an equilibrium price is the price at which a seller can sell a product and stay in business, and at which consumers are willing to pay that price. So you have to keep that balanced. Otherwise, if you charge too much, people aren't going to buy the product and you won't be able to stay in business. So we have our two equations. This is what the farmer is willing to sell, and this is what the grocer is willing to purchase. Okay, so what's the equilibrium price? When these two equal each other, which makes sense. So since x is already solved or isolated by itself, we can simply use substitution. Set both of those equal to each other. Okay, so when we do that, we set 100p minus 25 equals negative 150p plus 655. And then getting all of our variables onto one side, adding 150p, we get 250p to the left, adding 25 equals 680, and dividing by 250, we get 2.72. So we can make our conclusion that the equilibrium price is $2.72 per bushel. This next example deals with distance, rate, and time. And one thing you need to know is this formula here. Distance equals rate times time. Okay? D for distance, R for rate, T for time. So a plane flying with the wind traveled 700 miles in 2 hours. Flying against the wind, the plane traveled only 660 miles in 2 hours. We want to find the rate of the plane in calm air and the rate of the wind. Okay? So we've got two variables we need to solve for. Rate of the plane in calm air, okay, and the rate of the wind. So that's going to help us set up our variables. Okay, so we're going to define our variables here. So step one, we define our variables. So what do we want? Well, we want the rate of the plane in calm air, so we can call that R1, and we want the rate of the wind, so we can call that R2. Now we have to think about it. The rate of the plane with the wind, that's that first part of the problem here, is a plane flying with the wind traveled 700 miles in 2 hours. Okay, so with the wind, 700 miles in 2 hours. So the rate that we can talk about, the rate of the plane with the wind, is going to be the rate of the plane plus the rate of the wind, because you can imagine the wind is helping push the plane along. So we're going to add those two rates together. Okay? The rate of the plane against the wind. Now picture the plane is going in this direction, but the wind is head on, okay? So that means the plane has to fight against the wind that's coming towards its face, essentially. So we're going to take the rate of the plane and subtract the rate of the wind. And that's how we're going to talk about the rate of the plane when it's going against the wind, because we were given the fact that the rate of the plane against the wind traveled 660 miles in 2 hours. Okay? All right. So now we need to come up with our equation dealing with this distance equals rate times time. Okay? So we're going to move down here. Let's talk about our information with the wind. Okay? So with the wind, using distance equals rate times time, we traveled 700 miles. We said the rate of the plane with the wind was R1 plus R2, so that's our rate. And our time, we traveled 2 hours. Okay? So all I did was I divided both sides by 2, and we got our equation here. So 350 equals R1 plus R2. But now we need to talk about the plane going against the wind. So again, we're going to use distance equals rate times time. This time, we were told that the plane only traveled 660 miles, so that's our distance. Our rate that we talked about this up above, rate of the plane against the wind, was R1 minus R2, and we still traveled only 2 hours, so that's our time. Dividing both sides by 2, again, gives us our equation here. 330 equals R1 minus R2. So what we have ourselves here is we have ourselves a system of equations between those two equations. 350 equals R1 plus R2, and 330 equals R1 minus R2. So what I want you guys to do now is solve this system. Okay? So pause the video, solve the system for R1 and R2, and check back. Okay, so when I solved the system over here, I noticed that my R2s had the same coefficient and were already opposite signs. So I could go ahead and just combine these two equations right then and there. So 350 plus 330 is where I got 680. R1 plus R1, I get 2R1. Dividing both sides by 2, I get R1 is 340. And plugging back into one of these equations, we get R2 is 10. So now we just have to make our interpretation. Remember what R1 represents, the rate of the plane in calm air, and R2 represents the rate of the wind. So now we answer the question. The rate of the plane in calm air is 340 miles per hour, and the rate of the wind is 10 miles per hour. If you have questions, let me know.